Okay, now this is going to be a class for parabola. So first of all, what is a conic? Conic is defined like there is any line called directrix. It is called directrix. Next, there is any point in the same plane here, and which is a given fixed point. That's a focus. Okay. So now we consider any point in this plane which satisfies a condition like this is any point S. Okay, let us name it P, and this focus is S, and you draw a perpendicular from here which will meet it at M. Okay, the directrix, it meets directrix at M. So join PM, it's done, and we have to join PS. Okay, now conic is defined as the ratio of PS by PM is equal to E. The only condition here is that the point focus S should not lie on this directrix. Okay, now here, so this is called E, this is a constant. We say E is the eccentricity of the conic. Eccentricity. All right, now it's called the eccentricity of the conic. Next, there are various cases. At first, basic definition sum. From the focus, draw a perpendicular to the directrix and then extend this line. This is known as the axis of the conic. Alright, where the axis meets the directrix, that is this point, this is called O, this is called as the vertex. Oh, sorry, there is a brief mistake here. This is not the vertex. Wait a minute. This is the point, any point which meets axis and the directrix. So what we do is we draw the conic. First of all, let's draw for a parabola. For the parabola, E is equal to 1, which means that this distance and this distance should be equal. So its figure comes out to be like something this. Alright, here this point, okay, this is point where conic meets the axis. This is known as vertex. That earlier concept was a bit confusing one. Leave it. This is nothing like vertex. Okay, this is the this is the vertex, and it is a definition point where the conic meets the axis. Now we'll consider some cases. So first of all, when E equal to 0, we say it's a circle. When E equal to uh, like uh, 1, I have said already, still parabola. Next we will take E less than 1, this becomes a ellipse, and E greater than 1, this becomes a hyperbola. This is the basic conics we have to study. Now we're going to standard equations of parabola. So there are four standard equations, that is y square equal to 4ax, y square equal to minus 4ax, x square equal to 4ay, and x square equal to minus 4ay. Clear? So these are very basic things, so general. So I'm not gonna focus them much. Only I'm gonna say how to remember them. Vertex in each case would be 0 comma 0. Now focus, you see focus, if you remember the diagram, then everything's clear. For example, I'm giving an example of the y square equal to 4ax. So y square equal to 4x is just like a rightward opening parabola. So basically it is like something this is the axis, means axis, not the directrix. Okay, directrix should be somewhere here, which will draw later. First I am drawing the this parabola. Okay, this is the parabola. So this is y square equal to 4ax. This is the axis. The focus should be somewhere this side rightwards. So here to focus, so how to remember, it is a comma 0. Okay, and this is the vertex 0 comma 0. Why? The conic meets the axis this way, and you know it is here it's the case that SP by PM is equal to 1, so SP equal to PM, this is the case. So this is, consider this point, this is also on the what this parabola. So this point equal to, so this distance would equal to this distance. So here would be another point, and this is nothing, this is a perpendicular, this is like a perpendicular. So you can draw a line here, extend back, so you will get the directrix. And what's this point? The minus a comma 0. So this is the directrix. It passes to minus a comma 0, and it's parallel to, I mean, y-axis. So its equation is x plus a equal to 0. The focus a comma 0. Next, this is the vertex 0 comma 0. What's the equation of axis? It's the x-axis, x equals 0. And what's the equation of the tangent at the vertex? It's y equal to 0. Oops, sorry, it's y equal to 0, it's x equal to 0, my mistake. uh, so now, first of all, let's understand what is this x, this is y. This is nothing but this y and this x. If any equation is given, you convert it to this form, like y square equal to 4ax. Now for this, what would be the equation of tangent? This x plus a equal to 0. Not that this anything small x plus a equal to 0 for each and every parabola. This is not true for each and every parabola. This is true for only this parabola. Clear? So, next, let us move to what is called lattice rectum. Okay? So, this is the parabola, and this is the parabola. Now, this is the point a comma 0, which is the what? Focus. This is the tangent at the vertex. Alright? 0 comma 0. Now, what is a focal chord? Any chord which any chord of the parabola which passes through the focus is a focal chord. And what is a double ordinate? Any line which joins any chord. It's better to say that any chord. Clearly listen. Any chord which is perpendicular to the axis. This, these are the double ordinates. Okay. Next, if a chord is focal chord as well as a double ordinate, we say that it's a what? Lattice rectum. So this we get a lattice rectum. All right, this is perpendicular, this is a comma 0 passing through a comma 0, so its equation would be x equal to a. What's this point? If you substitute x equal to a in the equation, y square equal to 4ax, you get y equal to 4a square root over, that is equal to mod 2. I mean, it's like, sorry, 2a. So here would be the 2a, and like a comma 2a, and here would be something point, it's a comma minus 2a. Clear? So this is the, so what's its length coming? You see its length, it is 2a, and 2a, it's 4a. What's this 4a? From y square equal to 4ax, you get this 4a. This part, leaving the x and y square part, is the length of lattice rectum. Now, one thing of importance is that if two parabolas or any number of parabolas have same length of lattice rectum, then it is called they are equal. Same only means that not the length, the lattice recta are same. Like it is, this is one parabola, and consider one parabola like this, and this is its focus. Somehow or something it is made that this is the figure of the parabola, it's lattice rectum. Then this parabola and this parabola, they are equal. Okay, and you can say it is not possible that this is another existing, so this parabola should overlap with this parabola. So simple thing is that they are equal. Now coming to position of a point, like this is the parabola, and here is the parabola. Any point, like we define s1, like of any point, this is x1 comma y1, it can lie here or here or here. Okay, this is, I say, inside case, this is on the case, this is outside the case. Okay, Now s1 equal to, like, you put x1 and y1 in the curve. Okay, like we get here y1 square minus 4ax1. If s1 equal to 0, on case, and s1 less than 0, in case, and s1 greater than 0, it's going to be out case. Clear? Alright. Next, you see, now it's the parametric form. It's also quite important. I mean, say it's too important for this. Like, this is a parabola and this is a parametric form. It comes like you see, it's here 2 is multiplied and here a is multiplied. Okay, so like y square equal to 4ax. You have to make this y square, so this side should be square, something like a square. So what to multiply? Like 4a and multiply a, like x equal to a, not always some constant square. Okay, so you are going to get y equal to 280. Okay, so this is the parametric form, x equal to 80 square and y equal to 280. Next, so this parametric form is too important and is also very important and special for most of the problems. Coming to next thing, like you, this is the focus a comma 0, and this is what we call the focal chord. Now this is a point t1 and this is a point t2. What does that mean? Point t1 means its coordinate would be 81 square comma 281, and t2 means its coordinate should be at2 square, I mean comma 282. Excuse me, that's comma not plus. So it's this and it's this. Okay, now what would be the slope of this line? The slope of this line is 2 by t1 plus t2. That is slope of a focal chord. This must be remembered. Okay, now we are entering into one of the most important aspect of this parabola, tangent case. Tangent is what? Any line which touches the curve just only once. Okay, this is that tangent, it joins at this. Let us consider this point t, so it would be at square comma 2at. So slope of the tangent would be like slope of the tangent would be like 1 by t. You can see it is and derive derivate, so dy by dx you have to find, and you can see this is dy by dt is just 2a and this is 2at, so 2a by 2at it's 1 by t. Okay, next, slope is this, I mean of tangent, then of normal, what it would be? Slope equal to minus t of normal. You know that m1 m2 equal to -1 for two perpendicular lines. Clear? Next, we define something like t equal to 0. Okay, what's this t? You replace x by x plus x1 by 2. It's 80 square comma 2 or x1 comma y1 we say, then it's x and y by y plus y1 by 2, x square by x1 and y square by y1. So we get like here y square equal to 4ax. This implies replace y square by y1 equal to, this is 4a, and x you write x plus x1, mm, and this is by 2, so I am making it 2 already. This implies y into, what's y1? It's 280 equal to 2a into x plus, what's this x1? 80 square. Okay, this 2a, this 2a cancel. This implies dy equal to x plus 80 square is the equation of tangent at any point t on the curve y square equal to 4ax. This should be clearly learned. And how to remember this? You see, you know this is something from y equal to mx plus c, like mx plus c x. Okay, this is very big. Okay, mx plus c is a comparatively bigger term, mx plus c. Okay, this is a comparatively bigger term, this is smaller term. In smaller term you have to make it big, so you multiply, it's called t, and here you don't know, you have to be confusing about tx or ty. Okay, so it's ty and this is 80 square. Okay, you have to remember like that. So it's ty equal to x plus 80 square. Now comparing y equal to mx plus c and ty equal to, this is x plus 80 square. Just compare 1 by t equal to m by 1 equal to c by at square. Okay, clear? Because these two equations represent the same thing. This by this, m by 1 equal to this. Okay, now let us see something like c equal to, you multiply this and this cancel, c equal to 80, equation 1. And next you see here c equal to m, this is 80 square. Okay, replace c by 80. So what you get? 80, I mean, this is clear. Now replace, now you have to eliminate just t. So t equal to c by a, from here put in this equation. So you get c equal to ma c square by a square. So it's c cancel and you get c equal to a by m. Okay, c equal to a by m. This should be remembered.